Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. The intensity of the distributed load on the simply supported beam varies linearly from 0 to WO. Derive the equation of the elastic curve. Find the location of the maximum deflection and its value. So here is the figure. Then let's have the reactions first. AY, RB. RB is not important as long as AY is correct. So summation moment B is 0. So we have AY times L minus 1/2 of L times WO times L over 3 equals 0. So AY therefore is WOL over 6. So RB is WOL over 3. Then let's section. There's only one sectioning here. So that's X. Then call this W. W is WOX over L. W as to X equals WO as to L. So W is WOX over L. So therefore, the differential equation of the elastic curve is AY, y double prime equals WOL over 6 times X minus 1/2 of X times W, which is WOX over L, times X over 3, moment arm. Simplifying AI, y double prime is WOL over 6 X minus 1/6 WOX cube, 6L. So integrating once, EIY prime equals WOL x squared over 12 minus WOX to the fourth over 24L plus C sub 1. There is C sub 1 because there is slope at A. But there is no C sub 2 because when X is 0, Y is 0, it is a support. So EIY equals WOL over 36X cubed minus WOX to the 5 over 120L plus C sub 1x. There's no C sub 2. So let's evaluate C sub 1, set x boundary condition when x is L, y is also 0. So 0 is WOL over 36 times L cubed minus WOL to the 5th over 120L plus C sub 1 times L. Therefore, WOL to the 5th L to the 4th over 120 minus WO L to the 4th over 36 divided by L. So C sub 1 is equal to negative 7 WO L cubed over 360. So substitute here, EIY equals WOL over 36 x cubed minus WOX to the 5th over 120L minus 7 WOL cubed x over 360. So the maximum deflection occurs where the slope of the tangent is 0 or y prime is 0. So that's the equation of the elastic curve, factoring out WOX over 360L. Then we have for the first term 10L squared x squared. For the second term, negative 3x to the fourth. And for the last term, negative 7L to the fourth. After we factor out WOX over 360L. So again, delta max occurs where y prime is 0. So we set this to 0 with C sub 1 known. So EI y prime equals WOL over 12x squared minus WOX to the fourth over 24L plus minus negative 7 WOL cube over 360. So what is common here is WO over 360, WOL over 12x cubed. So 0 equals WOL over 12x cubed minus WO x to the fourth over 24L minus 7 WOL cubed over 360. Factor out WO over 360L. Then we have for the first term 30L square, x square. For the second term, negative 15x to the fourth. And for the last term, negative 7L to the fourth. So we set this quantity here to 0, but let's rearrange. So 15x to the fourth minus 30L square x square plus 7L to the fourth equals 0. So our variable is x square. Then our a in the quadratic formula is 15. Our b is negative 30L square and c is 7L to the fourth. Remember that x square equals negative b plus minus square root of b square minus 4ac all over 2a from the quadratic formula. So therefore, x square equals negative of negative 30L square, so positive 30L square, plus minus square root of negative 30L square quantity square minus 4, a is 15 times c 7L to the fourth all over 2a, which is 2 times 15. So simplifying inside this radical, x square is 30L square plus minus 4L square square root of 30 over 30. If we set the sign positive, the value of x is more than L, so it is absorbed. So we use minus sign to solve for L. So using minus sign, L is equal to 30L square minus square root of 30L square minus 4L square square root of 30 over 30. X is 0.5193 of L. So that's the location of maximum deflection. And for the maximum value or maximum deflection, we substitute this into this equation. So EI delta max is WO times 0.5193 L over 360L. Then quantity 10L square times 0.5193 L quantity square minus 3 times 0.5193 L to the fourth minus 7L to the fourth. So solving for delta max, in decimal, delta max is negative 6.522 times 10 to the negative 3 WO L to the fourth over EI. So that's it for this problem.